When we use water from surface water resources, that water is taken out of that surface water system and therefore unavailable for natural uses within the surface water system. In the United States, about 75% of the water that we use comes from surface water sources, and that's because surface water is easily accessible for the most part, and that makes it cheaper. So it's cheaper to siphon water out of a river, for example, than it is to pump water out of the ground. So we just have to note that there's an opportunity cost. Whenever we extract water from surface water systems for any one of our different uses, which may include agricultural uses for irrigating crops, municipal usage, so that's water that goes to your tap, personal uses, so if you live next to a river and you take water out of that river, or industrial uses. Whenever we remove that water, it's removed from the natural environment, and so it's no longer available for those systems. As a result, we tend to greatly impact wetlands. And wetlands are land areas that are saturated or flooded with water, either permanently or seasonally. And whenever we take water out of surface water, it can impact these natural wetland areas. There are 3 types of wetlands. These include inland wetlands, coastal wetlands, and the man-made wetlands. We'll go through each one separately. Inland wetlands include a lot of different types of wetlands, and these account for about 94% of all wetlands in the United States. So they are the largest by far type of wetland that we have. And they include many different, I've listed about 8 here, ponds, estuaries, rivers, swamps. Some you may not have heard of, fens and bogs, marshes, and tidal flats. So all of these are inland wetlands, and most of these are not contacting the salty ocean water, and so most of these are fresh water. There's also coastal wetlands, which would include marshes, estuaries, coral reefs, and lagoons, and most of these are either partially salty or salty ocean water. So an example would be like a coral reef. That would be ocean water, and so it is salty. Estuaries are a mix of salt and fresh water where they mix together, so those are slightly unique. Okay, and then of course there are many man-made wetlands, and over time we are creating more man-made wetlands as we replace natural wetlands. These include rice paddies and fish ponds, and there's others, such as ponds that you might see in neighborhoods where they're trying to create a wetland for surface water drainage to go to. And so man-made wetlands are very important for agriculture and for feeding people. Why do we need wetlands? There are many different purposes for wetlands and different services that they provide for humans and for the natural environment. So wetlands are great at resupplying aquifers. So water that sits in the wetlands can then percolate through soil and recharge groundwater systems beneath. They're, especially the man-made wetlands, are great for food supply. So predominantly fish and rice are grown in these man-made wetlands, and rice supplies about 20% of the world's food. So it's a critically important food source. Wetlands purify and filter polluted water, and this can include lots of different types of pollutants. So it can include agricultural chemicals, so as the water runs off a field that's been treated with different fertilizers or pesticides, that water can get filtered as it goes through a wetland that's downstream from the field. They also are good at filtering heavy metals from mine and industry waste that flows out of a mine. And in many countries where we don't have access to great sewage systems, if any, wetlands are good for filtering human sewage so that it doesn't get into other surface water systems. which are then used for water consumption. So they're critically important in developing nations that don't have adequate sewage systems. Wetlands help to store water, and also they help to provide water for wetland plants, and they prevent soil erosion because it slows down the water, so it's not running as fast. When it encounters these wetlands, it slows down, and that way it's not eroding soil banks along rivers. Wetlands provide flood prevention because they act like a sponge whenever there's a big water or storm system that comes through and there's a lot of precipitation. The wetlands can absorb some of that precipitation so that it doesn't fan out, to make a river jump its banks. Instead, that water can get funneled into wetlands, and then it prevents floods. We saw in Houston when there was a hurricane very recent, in recent years, a lot of the flooding that we see in Houston is because a lot of their wetlands have been filled in, and so then when it does rain, there's nowhere for that water to go, and so it floods streets and it floods people's yards and houses, and so a lot of that is because the wetlands that used to be there have been filled in. And then finally, wetlands are great for biodiversity hotspots. So we know wetlands are very important. Let's talk about how much we've lost in terms of wetlands. And before we talk about the percentage of loss of wetlands, let's think about the fact that wetlands, even if they're intact, they can be damaged by contamination. So if they get too much nutrients like nitrogen and phosphorus, that can cause algal blooms that get out of control, and with a process called eutrophication. And other water pollutants and air pollutants can also get into wetlands. But we're going to focus more on the loss of wetlands. So wetlands can be lost when water is diverted and it doesn't go into the wetland anymore. So when we have a dam or a canal that diverts water or holds water back so it doesn't go into a wetland, that's going to cause a wetland to drain and be lost. Often wetlands are drained or filled for agricultural use or to grow trees or forest-related use. And then we pave over wetlands so that we can pave over them. Often if we want to put a road through a new area, then we'll pave over a wetland. If you want to build new housing development in an area that was once wetland, then it could be paved over. Globally, we've lost 64% of all wetlands just since 1990, and if you go back to 1700, since 1700 we've lost 87% of all wetlands around the globe. If we look just at the United States lost more than half of the wetlands that were present in the United States by the year 1984. After 1984, there was wetland conservation in effect, which significantly slowed the loss of wetlands in the United States. So we're not losing wetlands at a very quick pace. In some years, we're actually gaining now. So if we look at the United States and what we're losing wetlands to, and again, these numbers are smaller than most parts of the world because we have legislation that prevents overall loss of wetlands. But basically, whenever we lose a natural wetland area, we're losing it to things like agriculture. So the light green slice of the pie, that's about 20% of, 13%, looks like a bigger piece of the pie. Silviculture, which is almost 40%, that's for cultivation of trees. Development, about a quarter, and other land uses, about 20%. That's what we're filling in wetlands for. And then if you look at the loss of wetlands in the United States from the 1950s until 2009, this is very telling. You can see that up until the 1984, when we enacted legislation to protect the wetlands, you can see the loss of wetlands was much greater than it is now. So from 1950 to 1970s, we lost 450,000 acres of wetlands, and then from 2004 to 2009, it was only a net loss of 14,000, and then from 98 to 2004, we actually had an increase of 32,000. So it's important to note that with our legislation, with our laws that protect wetlands, they don't say that you cannot develop a wetland. These laws say that if you develop a wetland, you have to replace it somewhere else. So the same amount of acreage that was lost in terms of wetlands has to be recreated somewhere else. And this would be then a man-made wetland. It may not be serving the same functions that the old wetland was serving, and it may not be the same quality. So overall, we're not losing acres of wetlands, but we might not have the same quality of wetlands that we had before, and of course they're going to be somewhere else. Estuaries are unique areas that are impacted when we divert water. An estuary is a bay or river delta region. So you can imagine a river that's flowing into the ocean, and when that river is flowing into the ocean, generally it fans out as it gets right near the ocean, and the gradients or the change in slope, it tends to get very small, and so that river fans out. That creates this delta region, and then you have a significant mixture of freshwater and saltwater. So these are very unique environments where you have certain species that are adapted to somewhat salty water, but not really salty water. They're rich breeding grounds for fish and certain waterfowl. And like I said, these populations are adapted to somewhat salty water, but as less fresh water flows out of the river freshwater system, then that estuary is going to become saltier as more of the water is coming from the ocean and less is coming from the river. And some populations that have adapted to that somewhat salty condition may not be able to survive. So we see one species that's very visible that we're seeing an impact is the great egret. They nest and breed in estuaries, and they're experiencing habitat decline as these estuaries are suffering. If we look on a global scale, I wanted to bring up a very classical example of shrinking wetlands, and this is the shrinking Lake Chad. Lake Chad is really important geographically. It's in Africa, and you can see that it straddles a number of countries. And so as a result, there's socio-political issues that come up when this lake is shrinking, because each country is upset that they're losing part of the access to the lake. And so you can see in 1973, this lake really did straddle Nigeria, Cameroon, and Chad. But now the only parts of the lake that are still a lake, that have the blue in the map, are in Cameroon and Chad, and so the other two countries have kind of lost out on that lake habitat. The lake is only 1/10 the size that it was in 1973 today. And generally you hear mostly that people are saying this is due to water being diverted for irrigation upstream, and that is true, but it's also true that this region is experiencing less rainfall due to climate change. And so even if the water wasn't being diverted to the same, as much as it is, this area would still be experiencing issues because they're just getting less rainfall to recharge this lake. Also, there's increasing populations that surround the lake, so they're consuming the water at a faster pace. So this is an example of an area that's seen a large change in a fairly short amount of time in their wetland system.